Hello students, today we are going to start the topic function. Function is the base of calculus and calculus is the base of your IIT-JEE examination or your board examination. If you want to score good, you have to score good in calculus or you have to understand your functions, right? Function is a topic that will give you the base for all calculus or foundation of your engineering. So this is the topic where you will understand about the function, what are the function, how to define the function, and now one type of function or different type of function that we are going to read. So in this lecture, we are going to start with what is function, how to define this by different ways, by graphical method, by set theory method, or by definition, how we are going to start this. Let's start and enjoy this topic. Function. In this topic, just start with the introduction of function. In a day-to-day life, we come across the machine which accept input, right, and given output is there, right? Like if I'm saying there is a switchboard. In this switchboard, you can see like there are switches, right? And one socket is also there, right? And these switches are connected with some tube lights or the fans, right? That this is the fan or the bulb, right? Or let's say the washing machine, or let's say the TVs and all, right? So let this one is connected with the fan only. This one is connected with the tube light only, connected with the bulb, and other is connected with the washing machine and so on, right? So if I'll press the button, switch on this, so this fan will on, right? This will rotate, right? Similarly, if you are going for the second one, right, tube light will on and so on, right? So in this case, one input is given and we are getting one output, right? This is known as single task machine. But maybe if I'm saying like in this socket, I have a plug and that plug connected with this fan, bulb, as well as the washing machine. And there is one more switch there. And this is on, right? This is on. If you'll press this button, right, this is the button for this. So if you'll press this button, then at once you can see like fan is on, tube light is on, as well as washing machine is on, right? So this type of machine is known as several output with a single input, known as multitask machine, right? So we know that there are two types of machine. One is single tasking and second is multitasking machine. What we are going to study is the single task machine. This is known as function, right? So if we want to see with the diagram of this, right, let f be a single tasking machine. That's called the function, right? If f is the function, name as the machine which takes place, x give the input, right? We are getting the different output on this, right? We are getting the output as y. So input we are giving from there, we are getting the output from this, right? So single input giving you single output, like set A is there and this is set B. The mapping is from A to B is such that for the single one, it's mapping to single one. This is image, and set A element is known as pre-image. So A to B. This is called single tasking machine. A element of A can go to any one output, right? So this is known as function. This type of mapping is known as function. Now, let Gx is a function. G is that's multitasking machine. This is not a function, right? Remember, multitasking is not a function, right? So if I'm giving with the diagram also, we can show this. Set A, set B. Like elements are there and the inputs are in set B, few inputs are there. For this, I'm getting more than one output. For this again, I'm getting more than one output. And this I'm getting one output or more than one output. This is multitasking machine, and these multitasking machine is known as relation, that is not a function, right? Not a function. So if we'll assign some fx, or we can write down this as y is equal to fx. Let fx is 2x plus 3, right? If we are putting the value of x is equal to 0, at 0 we are getting 3, right? So input is 0 and output you are getting as 3, right? Second case, input is 2, output you are getting is 7. And if you are putting any value like -4 in this case, so when you are putting -4, you are getting -5. So after any input like 0 or 2 or -4, we are getting the different outputs, right? So f is a function such that we are getting single output, right? So this is known as single task machine. So strongly we can say ki f, the function f is a function. Now, one more example like we are going with, okay, let consider as gx is a function that's giving you 0 when x is prime number like 2, 3, 5, 7, 11, and so on, right? Gx is a function that's x is even, then we are getting 1, right? So is this a function or not? So it's a single tasking machine or multitasking machine. So what the input I'm giving is, say this is A, and what I'm getting, the output is known as B. Like first number, if you are putting x is equal to 2, right? When x is equal to 2, since 2 is a prime number, so you will get the value 0, as well as 2 is an even number, so you are getting 1, right? But if you are putting 0, at 0, we know that 0 is an even number, so you are getting only 1, right? So this is known as multitask because the value 2 is giving you more than one output. So this is called multitask machine. So this is not a function, right? So we'll go for more terminology like domain and range. Now we know what is function. So in this function, we can also identify domain and range. Domain and range. Every machine has some limitations, right? We can't put each and every values there, and it's not necessary every time you're getting values from there, right? So this having their own limitations, right? So if like I'm saying 1 upon x minus 1, some y or some fx is equal to 1 upon x minus 1, we know that at x is equal to 1, you are getting y is equals to 1 by 0. 1 by 0 is not defined, means we can't put the value x is equal to 1, right? So this machine y is equal to 1 upon x minus 1 will not take the value x is equals to 1, right? So this value x is equal to 1 is not on the domain of the function. This value is not acceptable input, right? So this is not in the domain of the function. But if you'll put the value 2, 3, 4, any value other than 1, this will be the acceptable input. So we can say, right, the function y is equal to 1 by x is defined for all the values except 1, right? What is the range, right? All the resulting outputs, right? If you are putting 2, so you are getting the value y is equal to 1 by 2 minus 1 is 1. If we are putting 3, then 3 minus 1 is 2, 4, 5, and so on. So these all are called range of the function, means domain set of all acceptable values, right? Range set of all possible outputs from there, right? Now, one example again for you. F is a function, the input is given A, B, C, and D, right? When we'll put A is equal to F is in the A, so you are getting 3. For B, 7, C, 8, and FD is 0. If with the Venn diagram, we can show that there are two sets A and B. The mapping from A and B is said that for A, B, C, D, this F is a function 3, 7, 8, 0. For A, you are getting 3. For B, you are getting 7. For C, you are getting 8. For D, you are getting 0. Right? So the corresponding values 3, 7, 8, 0, you are getting with respect to A, B, C, and D. So this is known as, or you can say this with the Venn diagram there. This is the function, as I said, this is set A and this is set B, right? So the elements of set A is known as the domain. And what outputs are coming, these are known as the range, right? Understand, maybe few more values would be there, right? So range are the only element that takes part in the association and that are the outputs, right? Now, image and pre-image, right? Fa is equal to 3. We are taking the example of Fa is equal to 3. Then F take input A and give output 3, right? So 3 is known as the image of A under the function F. Similarly, if I'm saying FB is equal to 7, so we can say this 7 is the image of A under function, and one more terminology is there, pre-image of 7, reverse of this, pre-image of 7 is B under the function F, right? Under the function F, right? Now, so now we are going with the mathematical definition of function, right? Let A and B are two non-empty sets. A rule or the correspondence of function f is such that every element in set A to a unique element in set B. Then f is known as the function from A to B, right? This is known as the function from A to B. The element in A should be mapped to two or more elements in B, right? And A and B are called the domain of the function and codomain of the function respectively. Respectively means this, right? F is function or not. See, there is an element C in this that's not takes part in any association, so this is not a function. Each and every element of set A must take part in the association, then only this will be the function. So this is the perfect example. This must not be a function. Why? Because C has no image in B, right? C is no image in B, so this must not be a function. Second case, only these two cases are there when this will not be a function. Second case, see X having one mapping, Y having two mappings. This is association with Q as well as S. So there are two mapping in this case. So again, this must not be a function. Why this is not a function? Because Y having two connections, two values. For one value of Y, we are getting two values, Q and S in set B. That's the reason this is not a function. Okay, so two things: no element in set A is there, right? That's not take part in this. And second, when A to B we are going, this is A, B, no element in set B, that's give you the two image, right? These two are the case when we can say this is not a function. Okay, now domain, codomain, and range. See, set A, let this is set B, mapping from A to B under the function f. A giving you Y, B giving you X, and C giving you Y, right? Don't confuse with Y again taking the two values. Y is not in the set A. Set the restriction in set A, not in set B, right? So domain A giving the value, B giving the value, C giving the value, and A, B, C all are giving single value. So for domain purpose, this is okay, right? Only that you have to see. Now, all the elements of set B is known as codomain. So this is X, Y, and Z. All three are codomain, right? And the association X and Y. This association means image are X and Y. So this is known as range, right? So the domain is ABC, right? Codomain XYZ, and the range is only the values X and Y. Okay, now graph of function, right? So what we have studied in set theory or in mapping, now we have to use in graph, right? How you use this, just we can see this. F is such that A to B be a function such that FA is equal to B. This small a belongs to the set A, small b belongs to the set B, right? And then AB is such that A belongs to N and B belongs to B, the usual notation, right? But if we are going to plot the graph, right, y is equal to fx, right? So this is x-axis and this is y-axis, right? And the function we are taking that y is equal to fx, right? So all the elements A is known as the FA and all the elements of B is known as the going for y, right? If we are drawing a line parallel to y-axis, right? Parallel to y-axis, and this will intersect the graph more than once, right? This will intersect the graph more than once. What is the meaning of this? See, for single value, let's say A, we're getting B1, B2, B3, B4, B5. Means if this is a set A and there is a set B from A to B, right? For any value A, you are getting B1, B2, B3, B4, and so on. For single values, you are getting multi-values in set P, multi-task function. That's the reason if any line intersect the curve more than once, right? The line parallel to y-axis, then this must not be a function, right? This is the simple method when we can apply this. See, in this case, we can see like this is B1, this is B2, and B3. B1, B2, B3, A. So this FA may be equal to B1 or B2 or B3. So single value A giving you the output B1 or B2 or B3. That's the reason this is not a function, right? Now, so now we know there are two terminology, domain and range. So first we are going to understand domain of the function. What is this domain? How we can go with the domain of the function. Domain. Domain of the function. Let's see the first, I'm giving you the example, y is equals to 1 upon fx. Y is equal to 1 upon fx. We know that if any function is in the denominator, so fx must not be equal to 0 because 1 by 0 is always not defined, right? Like y is equals to 1 upon x minus 1, x minus 2. So the domain is x minus 1, x minus 2 not equals to 0. Means x not equal to 1 or 2. So we can write all the real number except 1 and 2. Or we can write this as minus infinity to 1, union 1 to 2, union 2 to infinity, right? All is in the open brackets, right? Now, the second part of this domain is if the function is given y is equal to under root of fx. See, any function is given in the form of fx is in the under root or fx to the power 1 by 2n, right? So this must not be real if fx is negative. So fx must be greater than equals to 0. Then only we can say this is real. Like a simple example of y is equals to x minus 1 is in the under root. So the domain will be x minus 1 greater than equal to 0, or this x is greater than equal to 1, and this is 1 to infinity, 1 closed, infinity open. This is a closed bracket. We are just keeping the value 1, that's showing that this is the value 1 is satisfying there, right? Again, if we want to go for the values like say y is equals to under root of x minus 1 into x minus 3. So x minus 1 into x minus 3 greater than equal to 0. Make the number line. This will be 0 at 1. This will be 0 at 3. Mark both the point. Put any value greater than 3. So this will be positive, right? Then we know that this will change the sign. So this will be negative and then this will be positive. So this is going for positive, negative, and positive, right? What we require, product of this will be positive. So this is the portion and this is the portion. So minus infinity to 1, union 3 to infinity, right? This is called the domain or the values of x. So x must satisfy all the values between minus infinity to 1 and 3 to infinity, right? For any under root portion, right? Again, if we are going for if you are going for any function like log, right? There would be a special property for log, right? Log fx base gx, then fx must be greater than 0, gx must be greater than 0, but gx must not be equal to 1, right? All the three condition has to satisfy simultaneously, right? Next class, we'll start from this concept only.